The foibles of translation of fonts, that nice big E you see on this first slide is actually the West Fraser corporate logo, if you could just imagine a computer that has that. So that's my corporate plug for the day. So I'm not going to provide a lot at the front end and the back end for this talk, a little bit of the rationale for our project, and we've heard some already today about what the rationale is, and I'll describe it a little bit as I go through it. The ecological definition for riparian area is what we're wanting to focus on, trying to come up with one of those and then figure out how to map it. And then once we do get it mapped, a little bit about how we are proposing to use it in a management sense. So a few words. We've heard a lot today about natural disturbance approach and maintaining ecological function. And this is where the company's perspective on this is coming from. We are adherents to the idea that forests are dynamic and maintained function through disturbance. And we see that some of the things that we've been doing in forest management aren't necessarily going to maintain those functions over the long term, and we're looking for ways to improve that. So I won't repeat it too fast, but forest fires are the main thing in our area, and it's interesting that managers of both working forests and protected areas are trying to come up with the same kinds of things to maintain biodiversity and function over the long term by approximating disturbance regimes. But when it comes to riparian areas, we've got additional disturbance regimes, floods being one that George mentioned, but we've also got these guys that actually can be pretty significant disturbance agents when you see them doing this sort of thing. So they are a combination of flood and tree falling. So the long-term perspective is to ask what we can do with relation to this question. What do we have to do today to have these kinds of patterns that are created by natural disturbances again at some point in the future? And ask ourselves what we're doing and whether or not what we're going to do or proposing to do is going to give us those same outputs. And if it isn't, what can we do to make them a little bit more similar? So John mentioned this morning the Alberta ground rule system. This is just a repeat of it. So it's based on the width of a channel, whether there's a channel there or not. And once you've determined that, then you have a buffer approach that's prescriptive. So what are some of the problems? I'll repeat those from our perspective. One is it's not ecologically based. It's based on a classification of a width and then a determination of another width. There are some real application and interpretation issues. So John mentioned, and I think Rich as well, it's difficult sometimes to determine what that width of that channel actually is. And then it's difficult to determine how far away from that channel you are when you're trying to put a measured buffer out there. So the poor layout guy hanging the ribbon, and he can't even see the creek, and he knows he has to be 30 meters or 60 meters away. He's got a real difficult time in trying to figure out whether or not he's staying within that rule when he's actually hanging the ribbon. So it's difficult for him to, while he's actually away from the value he's trying to protect, determine whether he's staying within the rules. But the most important reason we think for changing the approach is what Dave alluded to in his talk, and that is that we're not sure that excluding disturbance from these areas is the best way to go to maintain function over the long term. So what we would like to try and do is find ways to introduce disturbance into these areas that we have been protecting up until now, and see if we can't do a better job of maintaining or approximating that natural disturbance regime. And lastly, John also mentioned this and a couple of others. This has to be integrated into an overall whole landscape approach for it to be successful. We can't continue to manage riparian areas and upland areas as separate pieces. So actually it's really kind of hard to find too many examples where an actual uniform width measured buffer has been applied on the landscape. This is about the only one I could find on our FMA. So if you did a strict interpretation of the rules according to the government system, this is what you'd get. Not very many of those are actually out there. Instead, we've got a lot of these. So we take the measured buffer and then we make it wider because of other factors such as topography or ecological site types, economics, access, things like that. So even though the nominal width is as specified in the ground rules, what we actually apply out in the forest is something like this. But it results in a corridor where we've actively excluded both fire, because we're trying to put out forest fires, and harvesting. And there's consequences to that kind of an approach that we would like to explore and see if we can come up with a better one. So where we're at now, and I'll throw in the fire guy's pun, is a transition between the way nature does it and the way we've done it. And we're trying to come up with a new approach. So the first thing we had to do is figure out what's riparian. And that sounds like a simple question, but it's not quite so simple when you get into practice, and I'll show you a few of the problems we've encountered. So what we've settled on is 3 things are important in defining whether something is riparian. The first is close to water, the classic definition of riparian. So if you're really close to water, even if you don't have any ecological characteristics that say you're related to being close to the water, you should be riparian. And in the case of large woody debris, based on Rich McCleary's research and others, most of the trees that end up interacting with water bodies grew within 10 meters of that water body, and that's just a matter of physics, the height of the trees and the chance of them falling and interacting with the water body. It just happens to be about 10 meters. It's actually 9 point something. So we picked a 10-meter function zone. If you're close to water, that's riparian. Then the other one is a classical definition of an ecological community that's clearly riparian. An example would be a wetland, but a floodplain forest where water is influencing the vegetation. Water is in the root zone. You get water-loving plants. You get different plant communities compared to the adjacent uplands. Those are riparian sites. But the third thing is a landform. So sometimes you have this sort of a situation where you have a valley clearly carved by water, and you have floodplains and terraces and wetlands, and then you have a fluvial hill slope. So that's a slope that's been carved out by water. And sometimes the top of that slope is a good place to put a riparian area boundary, and I'll talk a little bit more about that. So here's some examples. This is clearly an ecological boundary. It's wet to the left of Erin, and it's dry to the right of Erin, and you can see the vegetation response. So this would be a riparian area boundary, a classic one. Here's another one. You can actually see the creek channel on the left in this case, and the ecological boundary is right where Erin is standing. And so ecologically, this would be an appropriate place to say that's the boundary of the riparian area. Now clearly that's within 30 meters, which would be the traditional buffer that you would apply on a creek like this. However, behind him there is an old terrace that was actually also formed by riparian action, and then behind him, behind that, there's a hill slope. So it gets into a little bit of where's the right place to put the boundary. We can recognize potential boundaries along any of these creeks, but we've got to figure out the right place to put it and then be able to consistently apply that approach in our mapping. Here's another example, a creek in an incised little valley, and the appropriate place to put the boundary would be the top of those fluvial hill slopes. At a larger scale, you get these sorts of things. This is a river on our FMA, and I've approximated where the riparian area boundary would be using our protocol with the red arrows. Here's another one. You're starting to get the hang of this, I hope. On the left, there's a fluvial hill slope. On the right, there's a fluvial hill slope. It's interesting where the left arrow is, that's actually an old glacial fluvial terrace, but we're saying nowadays that that's not affected by water anymore, even though it was thousands of years ago. So, in summary, how we're going to define it, we're going to use ecosites and landforms. If there are no ecosites or landforms within 10 meters, if those are within 10 meters, then we're going to go back at least 10 meters. That's how we're going to work it. So we're going to build a riparian map for our whole area, our whole million-hectare FMA, and then we're actually going to take and make adjustments for that digital call when we actually do layout in the field, and we'll build a guidebook that makes sure that our planning folks are adjusting the boundary according to the ecological criteria that define the riparian area. This is going to bring us a lot closer on one of those problems that somebody mentioned earlier this morning, which is making the strategic level plan, the forest management plan, and things like how much land is available, and the way we do it in the field when we actually apply the protocol match up more closely than we've been able to do in the past. So that's another benefit to this approach. So the mapping process now. So the first thing we had to do was identify where watercourses were, and Rich McCleary's process-based approach is what we've done. So we've mapped that for our whole FMA. We then had to classify the watercourses according to his process-based classification. That's done. We had to figure out where we were going to draw the line, and we figured that out. And now we're in the process of digitizing those riparian areas, and we've done a couple of test watersheds, and there's actually a meeting with our contractor tomorrow to continue the process. And Glenn, what's that, next couple months?
Yeah, it should be.
And then we'll be done?
Yeah.
Okay.
Yeah.
So.
By the beginning of May.
So let's start with an example picture of an area on our FMA. Here's the Watershed River. This is a color orthophoto digital. And the question is where should we draw the riparian area boundary in this scene? If you take the trees off, and you start seeing things like this. This is the LiDAR bare earth hillshade. And you start looking at, well, where's the fluvial hill slopes? And I've just sketched some on here in red. And the two outer boundaries pointed to by the blue arrows are probably the extent of the last glacial recession. So somewhere between 10,000 years ago and today, water carved out that large valley. And clearly the river that's there today didn't do that over time. There was a lot more water in that river valley at one time in the past than there is today. So we initially thought about going all the way to that outer limits, and then thought, well, no, that's probably not the appropriate thing to do. And what we should do is try and get rid of that glacial history and separate that from what we're calling the contemporary riparian area. So I've just sketched on a couple of landform categories here. Take away the veg and you get these kinds of landforms. So in the blue there is a terrace left over when the glaciers melted. And in the green is a slope that was carved out by the rivers when the glaciers melted. But neither of those is riparian today. If you go back and look at the vegetation on them, the terrace is covered by an upland pine site on a dry site, and the old hill slope is a drier site today as well. So they're not riparian anymore, even though they were carved by water at some time in the past. So this is what we're after. We want to try and digitize the hill slope that corresponds to what's ecologically riparian today. And so there's actually a smaller creek or water course that goes through that old terrace, and then there's the corridor along the main stem of the Watershed River. So we take away the trees again and line that up with the top of those hill slopes. What we're trying to do is digitize back and forth between the hill slope layer and the ecological layer to get the line in the right place. And as I said before, this isn't trivial. It's going to be a little bit tricky, and we have to go back and forth so that we can do it consistently and approximate where the guy in the field would actually call it when he's out there. So we're trying to match up what the GIS exercise is with the field approach. So if you take a zoom in there, you can see that the line actually reflects the ecology. So on the corridor on the left there, within the river, you can see floodplains and areas where the vegetation is distinctly different from the drier terrace on either side. So that's about where we want to try and get it. Now the challenge will be, can we consistently do that for the whole FMA? Here's another example. This is not far from there, 12 Mile Creek. This is what it looks like with the vegetation on it. Take away the vegetation, you can see a clearly incised valley there with a creek down in the bottom of it. In this case, you don't have a lot of floodplains. So you've got a fluvial slope. In this case, probably was carved by the glacier. That's still dropping directly into the waterway. Here's the wet areas mapping. So you can see that it's showing wet down in the bottom there and wet on some wetlands up on top, but not wet on those slopes. So even though they were carved by water, they're not wet anymore. But they probably, in this case, because they drop directly into the water body, still should be considered as part of our riparian area. So put the wet areas on top of the veg here, and just kind of look at the area in the central left there, some areas that are being called wet by the wet areas mapping. What GreenLink, our contractor, does is uses a 3D visualization program called SoftCopy, and they've got the LiDAR and the Ecological up on the screen at parallel screens at the same time, and they're actually digitizing on the screen, and they can also get access to the underlying LiDAR data, such as the actual elevation and things like that. So it's sort of a real-time process that they use to digitize this stuff. And it's actually pretty slick, although I think I'd get a headache after wearing those 3D glasses for about 10 minutes. So here's where they've actually digitized the riparian area on that 12-mile creek there. And you can see the wetland area on the upper part there that they've digitized in. And if you remember where the wet areas mapping was, it's some areas that wet areas mapping was calling wet, they've said, no, that's not riparian. So wet areas mapping is useful, but not quite there. So what we're trying to do is amalgamate a bunch of different sources of information together to come up with the best approximation. And we think we're on the right path. This isn't new. We tried this a long time ago for our 1999 forest management plan, and in that era we just had ortho photos. And actually Jamie, who was working for Timberline at the company at the time, led that project, and the riparian areas were just drawn on air photos and then transferred to orthos and digitized in that way. So what we're basically doing is saying we got a lot better digital data and information products now, and we can upgrade this and do a better job. So our FMA is around 1 million hectares. These are the stats for watersheds. What we've done so far are 2 test watersheds identified here in red. And I'll just show you some outcomes from that process. Here's what they look like with the veg on. The water channels there are classified according to Rich's system. So the dark blue are fluvial channels and the light blue are seepage channels. And every other thing has been taken off this map. So there's other areas there which would be ephemeral and things like that. Take away the trees, see the topography, and then after the digitizing process has been completed, we've got fluvial channels and their riparian areas in green, seepage channels and their riparian areas in brown. And then we overlaid this with what the operating ground rules call for, just to see if we were getting approximately or more than what the operating ground rules were asking for. And in almost every case, the digitized riparian area is wider than what the operating ground rules called for, which suggests to us that the arbitrary distance of the operating ground rules, if we're really looking at conserving riparian areas, wasn't a very good approximation of the true extent of riparian. The one area where the ground rules actually call for a wider buffer is around that little lake in the left there that's surrounded by blue. So how do we want to use this stuff? So our first stab is maintaining ecological function. We're going to, after we get the mapping done, classify all of the area within the corridors into passive and active. Passive simply means that it doesn't have trees on it, it's too steep, it's too wet, it's too close to the creek. There isn't an opportunity to use harvesting as a disturbance tool. So that area becomes de facto protected, at least protected from forest harvesting. And then the remaining areas, we would like to harvest in a way that we approximate fire as best we can and maintain the various functions. And the one example I'll use is large woody debris. So we've been trying out different operational and research trials on this for quite some time now. Here's a shelterwood trial we tried on the Great River floodplain back in 1990. About half of the trees were harvested out of this. We got a variance to allow us to go right up to the Great River. And this was the sort of thing we thought would be appropriate for these spruce floodplains along the larger rivers. So that was done in the winter of 1990. About half of the area you see here was horse logged and the other half was done mechanized. This is what it looked like about 10 years later. The Great River is just to the left of this photo. You can see the young spruce trees. Those are a combination of natural regeneration and ones that we planted. And then here's what it looks like 23 years later. So you can see some of those young trees have grown up, and yet there's still mature trees on here. So our prescription for this site is to come back every 30 or 40 years and remove some trees, but always maintain tree cover on the site for a variety of ecological reasons. Here's another one, another trial we put in along the McCloud River floodplain in 2000. And note that the areas here are more than 60 meters away from the McCloud River, so under the current ground rules, we would put a 60-meter protected strip along the McCloud River and then clear cut here. But we decided ecologically that wasn't the right thing to do, so we did a strip shelter wood as one trial and a group shelter wood as another trial. And those pictures were taken a year or two after they were put in, and we were back there this summer, and things are coming along nicely. This is the regeneration in the group shelter wood on the better sites. It's somewhat uneven. In some sites we didn't get very good regeneration at all, but this is the sort of thing we're trying to get. And again, the intent would be to come back every several decades and harvest some and reforest some and maintain forest cover on the area over time. Here's another one. This is a very small creek, a Seepage Creek, a channel, doesn't have fish, which would, under the current ground rules, attract a 30-meter buffer. And what we did in this case was went to the ecological boundary with our block boundary, which case is the orange line on this map, which in many cases is much closer than 30 meters. And then we developed a harvest prescription that told the operators to take the pine and leave trees that were leaning toward the channel, dead trees and non-merchantable trees to maintain large woody debris function over time on this site. And this is what it actually looked like after that was applied on the ground. So the line of willow you see running from the back of the pickup to the left center of the picture is where the creek is. The orange ribbons you see in the background were the block boundary, so that's where the riparian area was. And then the green ribbon indicates leaf trees, or an indication of where the operator should be picking trees to leave. So that's how that got applied. And again, we're trying to have our cake and eat it too. We're trying to maintain function, but use a different tool, a faller buncher instead of a fire. So that's pretty much a summary of it. I should mention that this is not all my activity, and we've got two folks, Aaron Jones and Glenn Buckmaster, who are very involved with this project, also in the room here today. And this builds on a tremendous amount of research conducted through Foothills Research Institute and others. So we're really trying to get the science and the application of practice as close as we can in this case.